Well, it uses a stream of salt water
Right.
that comes from a jet. You then put a electrical current between the nozzle that where the stream's coming from and the surface you're trying to machine. You can then remove material at the surface by ion exchange. So it's very much like a battery. But
Right.
instead of in electroplating, instead of where you're plating whatever precious metal onto a cheaper metal, in our case, it removes the metal from one side but doesn't allow it to plate on the other side. So we can very controllably remove and very precisely remove material from the surface. We're doing it at an atomic level. So, we can do depths of 1 micron.
So what's the key difference between your technology and electrical discharge machining, which is what Syntem does?
Key difference is ours is athermal, so it doesn't require heat, which means it doesn't cause any sort of damage or cracking or anything on the surface. There's no recast layer. So that's key. Ours is, like I say, it uses it's an electrochemical process, so it's an ion exchange outside of being a discharge where it's actually ablating the surface, so removing
Mhm.
by force effectively. Ours is kind of related to as a soft process. It's
And
seen
so
very well.
the depth you go is much less than what we do, isn't it?
Yes, yeah, yeah. We concentrate on the top couple of millimeters of the surface of a component. We can do, as like I say, as little as 1 or 2 micron down to
Right.
a couple of millimeters. We do cutting where it's deeper, but then it becomes when you want to remove large amounts of material quickly. There's other methods. Ours is where it
Mhm.
wants to be done very, very precisely. So where it's very precise and you've got a very strict set of requirements, that's where our technology really works. If you want to
And so
brute force
what are
things,
some
we'll do it as well.
examples of applications?
So our three main ones are kind of deburring or edge break, which is the technical version of deburring, where you're putting an exact radius on a corner of a component.
Right.
Um,
Yeah.
Surface prep, which is replacing things like grip blasting. So we're
Mhm.
much more repeatable than grip blasting. We don't have all the environmental impacts. So doing a surface before coating, before painting, before adhesion, or just because it requires dressing for some reason. And then part marking. So for part marking, it's especially relevant to safety critical applications. So where there's a lot of stress and strain because we don't change the surface and we don't cause any kind of crack initiation points because there's no heat going into the surface. When the parts that are marked are used in kind of high stressful conditions, hot
Mhm.
conditions, whatever, it doesn't affect the metallurgy. So for them particular use cases, that it's a great technology. It's really easy to kind of document the return on investment for it.
So your main markets are what?
Precision component manufacture, and that
Okay.
spreads aerospace, defence, power gen, medical.
Mhm.
Main areas really are kind of our at the moment aerospace, defence, and power generation.